Again, we have to start by importing stuff. This is very familiar. And now this time we're going to use a Fuego melt inclusion composition. And we're going to assume it has 4 weight% of water putting in here and no CO2. And we can calculate a saturation pressure, just like you've seen already. So this time we're passing it the Fuego composition and we're using a lower temperature. Now we get saturation pressure of 1.3 kilobars. So, and that sort of replicates the example that Penny was talking about, where maybe you only have information about water. And now let's say we've been to the ion probe and we now have dissolved CO2 concentrations in a melt inclusion. So we can add that in. And within VESIcal, there's a shortcut for adding or changing the composition, which I'm using here. I think, in general, there's often many different ways of using Python to do the same thing. And it's just like in English, there are many ways of saying the same thing and having someone do that thing for you. There's no different in programming languages. And so you could just copy and paste that and change the CO2 content if you want. It's up to you, and how comfortable you are with the particular software you're using and how many of the features you know about. And so we changed that, and I've just printed the composition out to check that it really did change. And we're just converting from parts per million to weight% here. So we can calculate the saturation pressure again. You just copy and paste the same code from the cell before. And we see a huge difference, as you might have expected from what Penny was just talking about. So, difference between 1.3 kilobars and 2.85 kilobars. But maybe this isn't all the CO2. Maybe there's a bubble in the melt inclusion too that has CO2 in it. So, and perhaps we've managed to measure that using Raman. So we could add that in as well. And if you have enough information about the shape and the size of the inclusion in the bubble, you can calculate how much concentration that would be in the inclusion if you added it back into the glass. So we can do that. Now I'm saying there's an extra 2000 ppm CO2 that we've identified from the bubble. So we redefine it again, just check that it really has changed. So we could have it to get into, so otherwise you spend hours trying to work out how you've messed something up. And then we can calculate the pressure. And it's an even bigger difference.
So to me, this means that people saying plagioclase hygrometry is a minimum pressure. The question is, how useful is that? If the real pressure is 5 and you get 1, is that actually more misleading than not doing it? I think plagioclase hygrometry probably works very well in rhyolites and dacites where you have practically no CO2 in the melt. But in a basalt, I think we need to be incredibly careful when people are invoking a shallow magma storage region based on plagioclase melt hygrometry, because CO2 is, even in very water-rich arcs, is an incredibly important part of the barometer for melt inclusions.
And the reason that we're showing you these calculations here is just to give you an example of how easy it is to ask these questions with VESIcal and get answers to these questions with VESIcal. And in this VESIcal 2 paper that Penny's mentioned, there's lots of these plots that we've generated using VESIcal, and just pasted at the end of this file in the appendix is the code that Penny used to calculate some of these plots. And the reason we are not running them here is they will take a long time to produce. But you can run them if you want. You just need to be prepared.
I mean, it's not a long time. It's several minutes, but it's enough time to go get a cup of tea and a biscuit and come back to your code, which is what the cartoon is showing. It's not going to take days.
Hopefully. If it's taking days, there's something wrong, at least with VESIcal. But I can show you the outputs of what's going on here. Maybe I'll just jump to the final result. Yeah. So you can see for a particular composition, there's some different models, varying the amount of CO2 that you add into that system then has a huge effect, regardless of the model that you use. And Penny's done has got lots of these sort of figures and done lots of these calculations that she's presented in VESIcal Part 2.